Here's a handout that I just want to spend some time doing some review on. And this is image formation with a concave mirror. So there's about 8 points that I want to remind you of. This is a good summary of this portion of the chapter. And the first one is represented in this diagram. You notice that we have these incoming rays right here, which is indication with this arrow, and they hit the mirror, and they all are going to be exiting through the focal point. These are the reflected rays. These are the incident rays coming in. Here's the principal axis, and here is the center, and here is the actual mirror itself. So the first point that I want to make regarding this is that rays that come in parallel are going to exit through the focal point. So we have your parallel rays exit through the focal point. Second concept is that rays that enter the focal point are going to exit out parallel, which is represented with this. So the first concept of rays coming in parallel to the principal axis will go through the focal point. Rays going through the focal point will exit parallel. So that's going to be item number 2. Rays that enter the focal point exit parallel to the principal axis. Third major concept is that objects that are outside the focal point are going to create real inverted images. So objects that are outside that focal point create or have real inverted images. To remind you, a real image is when the light rays actually converge. So this is a real image, but it is inverted. So because it's inverted, the height of the image is going to be negative. It's upside down. However, the distance is still positive because it's on the same side of the mirror. So the distance of the image will still be positive. So now with this next one, if you notice we're taking the object, we're moving it closer to the focal point. What happens to the size of the image? Next major point is the image is going to increase in size as you approach the focal point. So as you get closer to the focal point, your image is going to increase in size. So we're going to increase the height of the image the closer you get to the focal point. And then something really strange happens at this point here. So take a look at this previous point. As we get closer and closer to the focal point, here we're very close to the focal point, and notice how the object is small, the image is larger. So the closer we get to the focal point, we increase the size of the image. Then, at this point in time here, if you hit the focal point and pass it, the image is going to flip. The image flips at the focal point. Meaning, what's going to happen is we're no longer going to have an inverted image, we're going to have an upright or an erect image. That leads us to this next one. Now we're inside the focal point, and your reflected rays, okay, this first one goes in, okay, and it goes through the focal point. The second one aligns itself to the focal point and then is going to exit off this way. It's a slightly different drawing. The reflected rays inside the focal point do not converge. However, what does converge are the sight lines. Sight lines do converge on the other side of the mirror. And because we are on the other side of the mirror over here, our image is going to be positive. So the height of the image is going to be positive. However, take a look at the distance. We're on the other side of the mirror. The distance of the image is going to be negative. So these things over here, they switch. We previously have an inverted image with a positive distance, then we have an erect image with a negative distance. And in this case, because we're using these sight lines and that their reflected rays never converge, we have a virtual image. So the image is going to be virtual, not real. It'll be erect, and the image with inside the focal point is always going to be larger than the original. The closer you are to the focal point, the larger it will be. The closer you get to the mirror, the closer to the actual size of the object that you'll be. So if you have a compact mirror and you're looking at it, it's a concave mirror, the closer that you are, that's going to be closest to the actual size. The farther and farther you pull the mirror away, the larger that the object is going to get.